Now let us do another example. We have to find the acceleration of m1 and m2, and we are given that m2 is greater than m1. Since m2 is greater than m1, m2 is going to go downward and m1 will be pulled upward. Now here in this situation, if you notice, P1 is fixed to the ceiling but the pulley P2 is free to move. So that means when m2 goes downward, pulley P2 will also be pulled downward with m2, and because of these two going downward, m1 will be pulled upward. So here there is a concept that you should understand very carefully. We are going to use it again and again about the displacement. There is a relation. If let us say that m2 goes downward with an acceleration a, m1 will be moving with some acceleration, but that will not be equal to a because of this free pulley. Now to understand this, now consider this. Let us say that m2 goes downward with a displacement x. The m2 is going down with a displacement x. Now that means the pulley will be pulled downward with the same displacement x. This means the string on the both sides of pulley P2 will also be displaced in downward direction by a displacement x. That means x on this string and also x on this string. So the total displacement of the string will be 2x. I'll write it here. The total displacement of the strings connected to P2 will be 2x, x on this string and x on this string. Now that means if this string is moved down by a displacement of 2x and it is the same string which is connected with m1, so that means m1 will be moved up by this displacement 2x. So m1 is going to go up with a displacement of 2x. It is very important to understand this concept. m2 is going down with a distance of x, and because P2 has strings on both sides and P2 itself is moving down, so it will again x displacement in this string and x displacement in this string is going to occur. So total displacement on the string will be 2x, and hence m1 will be moving up by a displacement of 2x. Now notice here that this entire displacement, this entire movement of direction, movement of masses is happening at the same time. So the time in which m2 moves downward with displacement x, m1 will move upward with displacement 2x in the same time. So that means if the acceleration of m2 is a, acceleration of m1 should be equal to 2a. To cover this displacement 2x in the same time the m2 is covering the displacement x. Now make sure you understand this. So this is the relation between the acceleration of m2 and m1. Acceleration of m2 is a in downward direction and it is 2a for m1 in upward direction. Now let us talk about the tension. Now the tension from here, let us say it is T. So from this point T, because it is the same string, so T tension will be here. Here it will be T. This tension will also be T. All the tensions in this string will be T because it is the same string which is going. But this string with which m2 is connected to P2, it is a different string. It is not a part of this one. So that let us say that in this string the tension will be in upward direction near m2, and let us say this tension is T1. The weight of m2 will be in downward direction, so it will be m2g, and m1 will be in downward direction, it will be m1g. Now another important thing here is that pulley P2 is moving with the mass, and we consider pulleys to be ideal. So we'll write a note here. You should memorize this note. It is very important for a massless body, because we are considering pulley to be ideal, and ideal pulley will be massless and frictionless. So for a massless body, sum of all the forces on it will be 0. Sum of all the forces will be this, and this should be equal to 0 for a massless body, because if it is massless then m will be equal to 0. So the summation of all the forces will become equal to 0. So that means for pulley P2, all the forces that are being applied on P2, the sum of all these forces will be equal to 0. Now on P2, if T1 is in upward direction, then near P2 it will be in downward direction. So there is T1 force in downward direction and there is T force in this string in upward direction and this thing in upward direction. So we can write here that 2T, T plus T should be equal to the force on the downward direction, which is equal to T1. So make sure you understand this. Now we can make equation. You can draw the free body diagrams yourself. I am directly writing the equation. You try it, make the free body diagram yourself and see if the equations are correct. Now for M1, it is moving, M1G is in downward direction and the body is moving in upward direction. So we can write T minus M1G, and this is moving up with an acceleration of 2a. So it will be equal to 2a, to M1a. Similarly, for M2, M2G in downward direction, it is moving down. So M2G minus the tension here is T1. It is not T, it is T1. So I'll write T1 and moving with an acceleration A. So it will be M2A. Now T1 here is 2T. So we can write it as M2G minus 2T equals to M2A. So we have this equation and this equation to solve. Now if you solve this equation, the value of acceleration that will come out will be equal to M2 plus 4M1 into G. You can solve them yourself. See if that you are getting the same equation. Now this means, now A is the acceleration of M2. So we can write here that acceleration of M2, it will be equal to A. So it will be M2 minus 2M1 upon M2 plus 4M1 into G. And the acceleration of M1, since it is equal to 2a, so it will be equal to 2 into M2 minus 2M1 upon M2 plus 4M1 into G. So these will be your answers. You should understand this concept of displacement. Make sure that you understand this. If you have any doubt, you can ask me again. But understand this, it is a very important concept. We are going to use it again and again.